The universe continues to expand, stretching endlessly into the void, more mysterious and vast than we could ever imagine. In 1929, scientists made a remarkable discovery. The very atoms in our bodies, carbon, nitrogen, oxygen, and iron, were forged in the hearts of stars. We are, quite literally, children of the cosmos. By 1957, we began to grasp that the night sky is not just a breathtaking spectacle. It is a mirror of the immense forces and energy shaping the universe, from galaxies colliding to stars being born and dying in spectacular displays. Yet, despite centuries of observation, most of the universe remains a mystery. Stars, planets, and galaxies exist in an intricate cosmic ballet, yet we often have no idea why. Humanity has always asked the same fundamental questions. Why are we here? Why do the stars shine the way they do? And what other possible destinies might exist beyond the limits of our understanding? Often, we ignore potential dangers or signals until they become impossible to ignore, until cosmic events demand our attention. One of the most fascinating and enigmatic celestial giants in our night sky is Betelgeuse, a red supergiant star in the constellation Orion. Betelgeuse is not just large, it is a colossal titan among stars. Its diameter is so immense that if placed at the center of our solar system, it would extend past the orbit of Jupiter. By comparison, our Sun would seem like a tiny ember. But this star is more than just size. It is a window into the life cycle of massive stars and the violent, beautiful processes that govern the cosmos. Despite its apparent brightness in the night sky, Betelgeuse lies over 640 light-years away, a staggering distance. Even traveling at the speed of light, a journey to this star would take over 6 centuries. Using current technology, it would take more than 12 million years to reach it, longer than the entire history of human civilization. Yet, despite this distance, Betelgeuse has begun to show alarming signs of instability that have captured the attention of astronomers worldwide. Although stars may appear calm from Earth, they are far from silent. Betelgeuse has long been classified as a pulsating red supergiant, meaning its brightness rises and falls in cycles that range from months to years. These pulsations are a result of the star's internal dynamics, the delicate interplay between gravity pulling inward and radiation pressure pushing outward. As a result, its luminosity can swing dramatically, from magnitude 5 to magnitude 0, making it one of the most variable stars visible to the naked eye. In February 2021, Betelgeuse's brightness dropped to a V-band value of 1.614, one of the lowest levels recorded in decades, alarming astronomers and sparking widespread speculation. Its intense red color, caused by a surface temperature of approximately 3,500 Kelvin, is cooler than the Sun's 5,500 Kelvin. While the star's immense size gives it overall luminosity, its cooler surface temperature means it emits less energy per unit area than our Sun. The most intriguing aspect of Betelgeuse lies beneath its glowing surface. The star is running out of hydrogen in its core, the fuel that drives nuclear fusion and keeps the star stable. As the hydrogen fuel depletes, the core contracts, and the outer layers expand. Helium begins to fuse into heavier elements like carbon, oxygen, and even neon in a process called helium shell burning. But unlike the stable hydrogen fusion in younger stars, helium fusion is sporadic, releasing bursts of energy that cause the star's outer layers to expand and contract unpredictably. These expansions and contractions generate stellar winds, colossal streams of particles and gas that blow away from the star at incredible speeds. Over time, these winds can strip a star of a significant portion of its mass, further destabilizing it and affecting its eventual fate. The outer layers of Betelgeuse, expanding and contracting like a living heartbeat, create the pulsations we observe as changes in brightness. In a sense, we are witnessing the star's cosmic pulse, a rhythm that has been running for millions of years. Astronomers study these behaviors using photometry and spectroscopy. Photometry tracks changes in the star's brightness over time, while spectroscopy breaks its light into individual wavelengths, revealing information about temperature, chemical composition, and motion. Together, these techniques allow scientists to piece together a picture of the star's internal structure and behavior, connecting what we observe from Earth to processes occurring deep inside this stellar giant. But astronomers do not stop at observation. Using advanced computational models, they simulate Betelgeuse's internal dynamics, from nuclear fusion in the core to convection currents transporting energy to the surface. These simulations reveal the subtle dance of matter and energy inside the star. Hot material rises, cooler material sinks, forming massive convection currents that regulate the star's luminosity. This convective motion, combined with pulsations, creates patterns of brightening and dimming, almost like the beating of a cosmic heart. Betelgeuse's pulsations are not chaotic, they are rhythmic and predictable, driven by the delicate balance of forces within. As it expands, the star cools and dims. As it contracts, it heats up and brightens. These cycles are the result of the interplay between gravity and radiation pressure, a cosmic tug-of-war that continues until the star exhausts its fuel entirely. As a red supergiant approaching the end of its life, Betelgeuse is entering its most dramatic phase. Its pulsations are intensifying, its outer layers swelling and shrinking more dramatically, and its internal structure teetering on the edge of instability. Eventually, it will reach the cataclysmic climax of its existence, a supernova explosion, releasing more energy in a few weeks than the Sun will emit in its entire 10 billion-year lifetime. When this happens, Betelgeuse will shine as brightly as an entire galaxy, perhaps even visible during the day, before fading into a brilliant remnant, a neutron star or black hole. Even now, Betelgeuse's pulsations teach us about the life cycles of stars, the immense forces at play, and the delicate balance between creation and destruction in the cosmos. Observing it is like witnessing the heartbeat of a cosmic giant, a reminder that the universe is not static or silent, but alive and constantly evolving. Betelgeuse also forces us to confront our place in the universe. For centuries, humanity has looked up at the stars, imagining ourselves as explorers and observers. Yet stars like Betelgeuse remind us that the universe is far grander and more powerful than our comprehension. Its life and eventual death will scatter the elements that make up planets, and perhaps life itself, across the cosmos, a spectacular reminder that we are connected to the stars in more ways than one. So next time you gaze at Orion, look for Betelgeuse, a colossal, pulsing red supergiant, slowly inching toward its dramatic finale. Its story is one of cosmic scale, energy, and transformation, offering us a rare glimpse into the processes that govern not only stars but our very existence. Let me know your thoughts in the comment section below. If you enjoyed this journey into the heart of a red supergiant, don't forget to like, subscribe, and turn on notifications to explore more of the wonders of the cosmos.